All right. Yesterday we looked at converting exponentials into logs and logs into exponentials. Now we're going to do something with it by helping us solve equations. So if I want to solve 3 to the power of b equals 17 and I want to solve for b, right now the only way you know how to do that is to, well, get rid of exponent, you take the root of the exponent on both sides. Well, that helps me cancel out that and gives me a 3. I'm stuck with this b root of 17. Not so helpful. So another strategy is to convert this exponent into its log form. So let's go ahead and do that and see what we get.
Ow!
So log, what's my base?
3.
3. My log will equal my what?
Your exponent, so b.
My exponent, so b. And what number have I not used?
17.
17. So log b, base b of 17 equals b. Sorry, log base 3 of 17 equals b. Now this looks like a lot neater equation I could solve to solve for b. I just need to figure out what is log base 3 of 17. To do that,
Put in the calculator.
I'm going to put in the calculator. So log base, so alpha window, 5, log base 3 of 17 equals roughly 2.5789, blah, blah, blah. So 2.58. So b is about 2.58. If you wanted to keep it in exact form, you would keep it as log base 3 of 17. But if you were to tell somebody, how far are you from my house? I am log base 3 of 17, that doesn't make much sense. So we're going to kind of estimate our values here with logs. Note with logs, you will run into a lot of decimal values because it's growing really slow.
Angels at the door.
It's going to have a lot of decimals. So, there is a step before we convert that we want to make sure we do. That is to isolate our log, or in this case, isolate our exponent. Right now, this exponent, 18 to the power of 6x, has a 5 being multiplied to it. So let me get rid of that 5 by doing its opposite operation by dividing by 5. On both sides. Now I have that exponent all in its lonesome. So 18 to the power of 6x equals, I might as well just keep this as a fraction. I'll worry about the decimal later. That should be a 5. So now I have an exponent by itself that I'm free to turn into a log. And what does it look like as a log expression? Log with a base of 18 to the, what number goes here? 26 over 5. And it equals my exponent, which is 6x. So now this is a lot easier equation to solve, because all I have to do left is to get rid of that 6 being multiplied, and the opposite of multiplied is divided by 6.
The whole thing?
The whole thing.
Just making sure.
So if I want to keep it in its exact form, because it's going to be a crazy decimal, this would be it. But again, that doesn't make much sense in terms of usable numbers, so let's go ahead and estimate its decimal value. So log of 18, 26 over 5 divided by 6. Alpha window 5. Actually, first, I want to put the fraction in here. Now alpha window 5. Log base 18 over 26 over 5 divided by 6. And I get 0.095. More or less. 0.095. And I've solved this expression. So we want to be able to convert our exponents into logs, but before that, make sure that exponent's by itself. So as I look at this problem, e to the power of x minus 1 minus 5 equals 5. What should I do first?
Convert it to log form.
Not yet. That e is not by itself.
Add 5 and then
Add 5 to both sides, and hopefully you meant this 5
Yeah.
here. So that's going to give me e to the power of x minus 1 equals 10. Now I have this e all by itself, so now I can convert it to a log. How do you convert e into a log? What's its shortcut? ln.
In.
Very good.
No.
ln is a short version of saying log with a base of e. That's my ln. So ln, well, what is that ln equal to? It equals my exponent, so x minus 1. And it's ln with the value of what goes here? 10.
But can you just put X?
Yeah. No, you have to grab the entire exponent and that goes here.
Okay, I got it. Never mind. My fault.
So ln of 10 equals x minus 1, which gives me one more step to solve, which is add 1 on both sides. And my exact form is ln of 10 plus 1 equals x. And again, let's go ahead and round what the decimal is going to be for that. So ln of 10 plus 1. ln on your calculator is right here on the left side. Third button up, ln of 10. Now make sure you close the parentheses because you don't want to actually accidentally calculate ln of 11 plus 1, and I get about 3.3. So that's roughly 3.3. I'm doing decimals and real values because you're going to see both. You're going to see, give me the actual value of this and give me the decimal value. So now it's your turn. Go ahead and solve these two expressions. Okay. So for this first problem here, what is the first thing I want to do?
Subtract 3.
Yeah, I need to isolate my exponent. So let me move the 3 over. That gives me 9 to the power of n plus 10 equals 78. Now, I'm free to convert this into a log. So how does it look like as a log? Log with the base of 9 to the 78, and it equals n plus 10. Oops, I'm doing kind of a Disney number. N plus 10. Which leaves me with just one more step to solve for n. Subtract 10 on both sides. I get log base 9 of 78 minus 10 equals n. So approximate that value. N is roughly
1.92.
sounds about right. 5 log base 9 of 78 minus 10. Ooh. Yep. She got negative 8.02.
Whoa.
Negative 8.02.
I put the minus 10 in the front.
Oh,
Outside?
again, watch out for that. You want to make sure you close the parentheses.
Damn.
Otherwise, what you calculate was log base 9 of 68.
Okay.
That's completely different from log base 9 of 78 minus 10.
I won't do it again.
Next problem. First thing I want to move over is looks like it's going to work out the exact same as the previous problem. Move over this 5. I get 11 to the power of n minus 8 equals 59. Which now I'm free to convert it into a log. So log with the base of 11 in terms of 59 equals my exponent. And then one more step to go. Move that 8 over. I get my exact value of log base 11 of 59 plus 8 equals n. Again, note that this is all collectively one number, and then we have to add 8. So let's approximate that decimal value. Alpha window 5, log base 11 of 59, close the parentheses, plus 8.
Half an hour.
59, there you go, plus 8. Should have gotten 9.7. 9.7. Okay, so there's how we're going to solve some exponential equations. We're going to change them into logs because it's going to be a lot easier to solve that way. I just want to go over one more thing, so I'm going to cancel that. Let's look at this problem real quick, just to make sure you understand that you really have to isolate it completely. So what would you move over first?
6 to 6.
6. So let's subtract 6 on both sides. Negative 3e 7a plus 9 equals negative 12. And now what would you do?
Divided by negative 3.
Notice how my exponent here, e to this power, still has this negative 3 being multiplied to it. So I need to get rid of that negative 3 before I convert. Like so. Now I get an exponent that's by itself. E to the power of 7a plus 9 equals 4. Now I can convert this. So what does e to the power of 7a plus 9 equals 4 look like as a log? ln of 4 equals 7a plus 9. So now I have kind of a linear term that I can just go ahead and move everything over and solve for a, which I'm going to go ahead and cheat a little bit. Let's subtract 9, so ln of 4 minus 9, and then I'm going to divide by 7. That equals a. So I just want to point out everything must be moved. Everything added, subtracted to the exponent, and multiplied and divided to that exponent. Needs to be alone. So, let's go the opposite direction. Notice with our exponents to logs, I end up with some crazy decimals. Luckily, that's not going to be the case when we go the other direction. So when we go to log and exponents, we're going to have more rational numbers, and they're just going to be very big rational numbers most of the time.
So what you want to do is,
So what I want to do is look at this log. Is it by itself? Yeah. So I can go ahead and convert it to an exponential form. So in that form, what's its base? What number is being raised to a power?
X. I mean 4.
4. So it's the same base as the base of your log. So that is 4. What is going to be my power, my exponent?
6.
Your exponent is what your log equals, so 6. And that equals
X.
x. Well, look how that's a lot
Exponential.
nicer looking problem. 4 to the 6th power equals x. So let me just find out what is 4 to the 6th power. 4,096. Now, I want to mention this early so that we can have some practice. Technically, if I want good standard practices with math, once I find my value, I should plug it back in to make sure it works out. Just so I know I'm right. So I should take this value, plug it in for x, and I should get a 26. So the next test, you should be able to do that to check your work. Everybody should get 100 because you should know if you're right or wrong. Especially with logs, let's go ahead and test. Because as I'll show in a moment, logs are very particular. If I were to plug in a negative into a log function, it does not like it. So we got to watch out what x value we end up with. Sometimes it may kick it back and we get that extraneous solution. Not today, but we're going to practice today so we can get familiar with it down the road. So I'm going to try to find what is the log base 4 of 4,096. Hopefully it's 6. Alpha window, 5, log base 4 of 4,096, and yes, that worked out.
I'm really gonna start crying, bro. Bro, my body just crying. I don't
So this is the solution. X equals 4,096.
I don't understand. But the house is finished.
Now, just like exponentials, we need to make sure the log is by itself. What should I do before I convert this? Divided by 9. Look how this 9 is attached to my log. That's a no. So let me divide by 9 on both sides. gives me log base 7 of k minus 3 equals 0 divided by 9 is 0. Now I can turn it into an exponent. So what's going to be my base? 7 raised to the power of 0. This is your power. And that equals k minus 3. Okay, looks like a pretty easy linear equation to solve. So let's go ahead and do it. What's 7 to the 0 power?
1.
I didn't teach on that.
How'd you know that?
What's anything raised to the 0 power?
0.
1.5. Got it.
It is 1. It is 1. I was just
How did you know that? 7 to 0. 0 to 7
We learned this a while back.
Yes.
We said everything.
Everything to the 0 power.
Oh, wait.
One.
He was 1. Okay. Now I heard.
Oops, 0 power
How did I forget that?
is 1. Even if I take good old e, which is an irrational number, and I raise it to its 0 power, it's going to be 1.
So to the X power.
So thank you, JD, for not saying 0.
I thought it was looking for his
Now,
We broke the teacher.
let's add 3 to both sides.
Wait, what?
And I get k equals 4. So like I said, these numbers work out a lot nicer when we're going from log to an exponent, but not the other way around. Let's test our work, because like I said, we should start doing that now. 9 times log base 7 of 4 minus 3 should equal 0. So 9 times log base 7 of 4 minus 3 is 0. All right. So k does in fact equal 4. I don't have to throw that number away. Now it's your turn. Solve these two expressions. Note with this one right here. What's its base? This is log base of
10.
Very good. If the base is missing,
And it's always going to be a 10.
it's always going to be a 10.
I know it by heart.
All right, let's solve this. So, first one here. What's the first step I want to do?
Divided by -5.
Yep, get rid of that -5 attached to my log.
Both sides. Both sides.
So that gives me log base 8 to the 3m equals -1. Next, I'm free to convert this into an exponent. What does that look like?
Put that
8.
8
Uh-huh.
to the power of
-1.
-1 equals
3m.
3m. Very good. And now I just have one more step. Divide by 3.
Both sides.
So I get m equals, well, what is 8 to the power of -1 divided by 3? 8 to the power of -1 divided by 3. It's a crazy decimal, but I have a hunch it might be rational. So let me turn it to a fraction, and it is 1/24. So m simplified is 1/24. Okay, the next problem. Log with base 10 to the 3x plus 7 equals 0. Looks like the log's by itself, so how does this turn into an exponent? 10 to the power of 0 equals
3x plus 7.
3x plus 7. All right, let's solve for x. 10 to the power of 0 equals 1 equals 3x plus 7. And then now let's subtract 7 on both sides. I get -6 equals 3x. And last but not least, divide by 3. Should have gotten x equals -2. Nice that we get nice whole numbers. X equals -2. Let's plug it in to make sure. 3 times -2 is 6. Or sorry, -6. -6 plus 7 is 1. Log base 10 to 1. We'll see tomorrow with our basic properties. Any base to 1 will always equal to 0.
I was thinking that when you did 3 times -2, I thought you were going to get 0, right? Wait, are you?
Yeah.
Yeah, you
Okay.
are. Yeah.
What? No, 3 times -2 is -6.
-6. Okay, but if it was like you get the answer past the equal sign, right? If it was like that, you could just keep guessing for a random number to get your answer past the
I mean, you might luck out with logs,
Mm-hmm.
but if you try to do that with exponents, good luck trying to guess -8.02.
Oh.
Good luck trying to guess 9.7. And that's just rounded. So, you may want to watch out. These are not the types of problems you want to guess.
I'm not guessing.
Now let's look at a bit more college algebra type of problem.
Oh my god.
College algebra.
So the difficulty just increased by a little bit. Like I've been doing, always good practice to check your answer, especially with logarithms. Because as you see, logs don't like negative numbers. Always check for strange solutions. It won't happen today, but it will happen pretty soon. I have the expression, log base 2 of x squared minus 1 equals 3. I have nothing attached to my log, so I can go ahead and turn this into an exponent. And what does it look like as an exponent? 2
With the power of 3
equals
x squared minus 1.
x squared minus 1. All right, 2 cubed is 8
Oh, so I get the 2 times
equals
8.
x squared minus 1. And now let's pause for a second.
Pause.
I have a square, quadratic. Let's remember, how do we solve quadratics?
Oh, you gotta ask equal 0.
Has to equal 0. Very good start. So let me subtract 8 on both sides.
Oh, I see what you did.
I get 0 equals x squared minus 9. Now how do you solve? Graph it. So let's go ahead and graph x squared minus 9.
X minus 3.
And I see my x-intercepts are at what values?
3 and -3.
3 and -3. So x equals 3 and -3. Yeah, with this type of problem, you had lots of options. You could add 1, give you a 9, then square root both sides, plus or minus this. You could have factored this. This factors into x plus 3 and x minus 3. Using the zero product property, would have got you here too. So it was a simple enough project. I mean, quadratic to start off with. Now, let's check. Let's make sure 3 and -3 work out here. Because I do see one of my x values is a negative. I need to be careful with that. So let me pull my calculator. Log base 2. Let's start off with 3 squared minus 1. And that equals 3. All right? Now let's try -3. And please remember to put your negatives in parentheses when you're squaring them.
Whoa.
And I get also 3. So both of them, 3 and -3, work out. So that is my solution. So same deal, except for instead of ending up with a linear term, we end up with a quadratic that we should know how to solve in our sleep by this point. So let me have you answer this problem. Log with a base of 10 in terms of x squared minus 5x plus 4 equals 1. Solve for x as an exponent. What's my base? 10
Yes.
to the power of
1.
1 equals x squared minus 5x plus 4. I see that I have a quadratic, which means my next step should be
Um,
Solving for x.
10.
solving for x. What should I do before I...
You know to solve that equation? No.
Yeah, set it equal to 0.
Talk.
Subtract 10 on both sides. That's going to give me 0. Still having some technical issues here. There we go. 0 equals x squared. Whoa.
Okay.
Yeah, that way.
X squared minus 5x minus 6. All right, we're almost done. Now, let me go ahead and graph this quadratic. Graph is over here. And I see my solutions are -1 and 6. So x equals -1 and 6. Or does it?
No,
You
You
gotta
should be
separate-
able to plug it in
Yeah,
for
okay.
x.
El Pepe.
I tell you they both will work. So x does in fact equal -1 and 6.